because
Okay.
in the book it said B0 and B1, but in the homework they said B1 and B2. So I kind of thought maybe that was a mistake. Anyway, on this one, it's probably the same as the homework, which was, I just changed mine. Oh, B1 equals 0, and they wrote B2 not equal to 0, but I think they meant B1.
Oh,
so that's
yeah,
what I'm
probably B1.
Equals 0 and not equals 0. So I think it's the third one.
Oh, yeah, never mind. I just had them switched.
Yeah.
So are you saying the first one?
No, so
no,
the
I think
third
it's
one.
B1, B1 is equal 0, and the alternate is B1 is not equal to 0. A residual. Okay, I'm just
it's the difference between the observed y value y and the value that would have been predicted. So I think it's the third one.
Yes, the third.
I remember doing the residual, but I don't know what it means. Calculated for each data point, so every
Well, I write it
residual.
down. It's the residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line.
Oh, okay, good.
Eating.
So a plot of residuals supports using linear regression.
Distribute.
What'd you say, Mary? I couldn't hear you.
First one.
Distributed. Is that one of the 5 things? That table? For residuals, it says support megaphones, shapes, and no pattern. Is that what this is?
No, I didn't find that in there. It was in the reading under the QQ plot.
Yeah, so I think it is the first. The residuals look normally distributed, yes.
Yeah.
Okay, use the confidence variable as the explanatory variable and the score as the response. Compute the residuals for the data using software. Okay, here we go.
It's the last lesson, guys.
I know. These just take forever. Take forever. Confidence is the explanatory.
Oh, hey, Derek.
Oh, Derek's on. Hey. We just stepped in. We got things rolling.
Sweet.
Okay. Confidence as the explanatory variable. Okay, scatter plot. Response is dependent. Okay. Response is dependent. I hate this. Sorry. I hate it.
I think we're all over it.
Yeah. Okay, I'm gonna make a scatter plot. Define.
Are you guys on number 8?
Yeah.
Okay.
No, we're on number 6.
On number
Sorry.
6.
Yes. I thought it was 8. I didn't look at it. I thought it was 8. But didn't it say, oh, it said for the next 8 problems.
Okay. No worries.
So I got the 8. Okay. Okay. Explanatory. Oh, response variable is the Y, right? So score is going to be Y.
Mm-hmm.
And confidence is X. Okay. Getter, plot, and make a line in it. Okay, then analyze regression linear. Okay. So we're putting score in dependent box and confidence rating in the independent box, right?
Yeah.
Okay. Save. Residual. What statement best describes the residuals? Okay. Oh, this is just our scatter plot, the first question.
Okay.
Residuals are negative 40 and 25. No, they're not negative.
Yeah, so I think it's they form a linear pattern.
Pattern, yes, that looks good to me. Or are all negative? No, they're not all negative. So it's the second one.
No.
Okay.
Okay.
Based on the QQ plot. Okay, let me make it. Let's make a QQ plot. Then we can base something on it. Okay.
I thought it was fairly normal.
Okay, QQ plot. Score and confidence and okay. Okay.
I don't remember how to do a QQ plot. How do you do it?
It's on analyze and then descript. Oh wait.
Oh yeah.
Descriptive. No, I don't want any. Thank you. Okay. QQ plots, what can you say? Yeah, I think fairly normal because they're all close to the line. That's what the QQ plot is for.
Yeah.
They're near the line, then they're good. I'm saying the second one.
That's what I said.
Okay. Use software, create a scatter plot, give scatter plot residuals plot on the QQ plot. Which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. Okay, so the first one is there is a linear relationship between X and Y. We check the scatter plot and we make a residual if it's a hot dog shape and no pattern in the residuals. So, oops.
Oh my goodness.
And yes, there is. Oh, I didn't do the residual graph. Wait, I thought I did. No, I guess I did. Okay, I guess I didn't. Okay, residual. Graphs, legacy dialogues, scatter, dot. Oh yeah, that's right. Um, Move the variable residuals to the y-axis. Oh, okay. Independent x-axis. Click OK. Okay.
So do you think it's the first one and the third one?
Oh, hold on a second. I'm still looking at the thing. So no pattern, bless you. No pattern in the residuals. So yes, the first one is satisfied. Okay. The QQ points are close to the line. So yes. Wait, where's that? The error term is normally distributed. That variance of the error term is constant for all values of X. I guess that's what it means. That's the third one. Residual plot, no megaphone shape. Yes. Residuals are normally distributed. I guess that's what they mean, the no megaphone and all that. No pattern in the residuals, yes. X values are measured without error. Okay, in the homework, they did some other graph thing on here, and I don't know how to get it, but the guy on the video, there's no way to check this. You can just, they were measuring without making errors. So I'm saying all 5, actually.
Oh,
You what?
All of them are satisfied. I think they're all, knowing the value of.
Wait, so does your
Y.
graph look like a megaphone?
No.
What does
Mine
your graph
doesn't.
look like?
It's just all everywhere.
Oh my gosh, this thing is...
Hot dogs.
See, mine looks like a megaphone where it's like kind of denser in one area and then it spreads out on the other side.
Is it the one called confidence rating mean studentized deleted residual?
Is what?
What does the graph say on the bottom and on the side?
Sorry, it's like if I try to scroll down it. So is confidence rating supposed to be on the bottom or on the side?
Mine's on the bottom.
Yeah, so mine's still on the right, the top right, it's more together, and then it kind of spreads out a little bit as it goes down to the left-hand side.
I'll text you a picture of mine. I guess I could share my screen, but I don't really know how, so I'm just going to text it.
I know how. Whoa. I don't really know how this works, actually.
Okay, I just sent it.
Except now it looks like it's freaking out.
No, no.
Stop.
Yeah, my graph is definitely not a megaphone, but they're all just like thrown like dart. So I think it's all 5.
I mean, what does everybody else's graph look like? Mary, did you say yours looked like a hot dog?
Yes.
Wait, it's trying to be the other one's side of the graph. I haven't gotten your picture yet, Rosalie.
Oh, really? I sent it in that group text. Oh, it's still sending.
Okay.
I live by a mountain.
I sent you one separately just because I thought it might go through faster.
Oh, okay. My cell service is crazy where I live. Okay, I sent it separately. Wait. Yeah. Oh, I think it just went. Maybe.
Okay, I'll wait for it. Okay, yeah, that's not what mine looks like.
Well, let's try 1 and 1, and then the first time we'll see what happens. I think it's actually good to not put everything the same.
Yeah, let's just, we can always go back to it.
Oh, yeah.
But I could have been, I mean, I could be doing it wrong. I don't know.
Actually, the one that you sent me, it does look like the first one, but this is the residuals one that I sent you. The first one.
Wait, so how do you do residuals? That's what I did. I thought. It says to make a residual plot in SPSS.
This one is regression.
And you do graphs. Where's the regression on here?
Yeah, the regression line is the one with both confidence rating, mean, and score.
Where does it tell us how to do that one, though?
It's in, I'll tell you. Which one? The residuals?
Yeah, the regression one, the one that you have.
Oh, that's residuals. So you have to go to, let me see if this is the right one. So, okay, first you have to make the separate line of data in the, it's kind of 2 steps in the column. which is, so you do analyze, regression, and linear. It's on 3.2 on the book. But
Yeah,
I'll tell you.
okay, I did that.
And then you do the next one that says residual plot. Because you're going to use the thing that it put in the last column. It gives you a new column when you do that. And then you're going to use that one for one of the X and Y.
Yeah, but so how do I make the graph with just the last column?
So then it's that 3.3 in the textbook. It says do graphs, legacy dialogues, and scatter dot. And then you go with the default simple scatter, so you click define.
Okay,
And
so
then
I just did the wrong. So then what's in the x-axis and the y-axis?
You leave the X alone, and
Okay.
in the Y, you put the residuals one. It says something about residuals in the name.
The unstandardized residuals? Oh, okay, that's what it is.
Yeah. And then click OK.
Wait, you leave the x or the y alone? Is that what you said?
You leave the X
Alone.
Yeah. Because the X is what you used last time. It's the same, so you don't have to change it.
It's not letting me like press OK though if I only have something in the y.
No, I meant you leave what's there. So it should be the because when I pull it
Okay,
up,
so
it already has
score
it in
needs to be in the x-axis then.
Yeah.
Okay.
Maybe. But except mine is not score. Mine is, maybe I did it backwards. Mine's confidence rating.
Well, because score, the x-axis is the dependent one, right?
So when
you do the opposite?
Maybe. When you pull that graph up and says okay, what does it say on the bottom and on the side?
Well, it says score on the bottom and residual on the side.
So maybe I did mine backwards.
But maybe not. I'm just wondering. X is the.
But is it a megaphone?
Dependent, right?
So what it said in the book is to use the
independent variable into the x-axis. So independent is. Yeah. So then yours is right.
Oh, it is. Oh,
because
gosh.
The confidence rating is the independent one.
Oh, okay.
Okay, so you had all of them marked then for that?
Yeah, they're just everywhere. It's not a megaphone. It's not any.
I know. I just meant on the question.
Oh yeah, all 5. Yeah, so I did all 5.
Okay, I have so many things in here now, and some of them are wrong.
I have way too many graphs going on, and for this next one, we have to find the slope.
Okay, so what is B1, the estimate for the slope?
So I think it's 12.695. Is that right?
12.695?
Yeah, 12.695.
That's what I think, yeah. Okay.
Now construct a 95 for, oh my goodness, confidence interval for B1.
That's okay, because that's just another SPSS thing.
I know, it's just so much.
I know. It's crazy. Regression, linear.
Okay, so Dependent is the score.
Statistics. Confidence intervals, regression coefficient. 95%. Continue.
Okay, my SPSS is frozen.
Oh, shoot. Okay, so mine says that it is, what are we supposed to put in? The lower bound? Okay, so I have 10.674. Does that match?
Yeah, my life shut down.
Shoot.
It quit unexpectedly, so I'm gonna have to reopen it. I think I had too much going on.
That's it. Too many SPSS. Homework we can do.
Seriously. Okay. What was the upper bound?
I have 14.715.
Okay.
Minus 24. So it's way below 0. So that means
So does it reject the null? Because the p-value is less than a?
Yeah.
Because p-value is less, yeah. P is low, yeah. For a hypothesis test, if you reject the null, what does it mean? It means there is sufficient evidence to suggest that sufficient evidence to suggest that
It's not zero.
hypothesis. What's the alternative hypothesis? Alternative, oh, not equal, right?
Yeah.
It's not zero.
Okay. So I think it's the fourth one.
There's insufficient evidence to conclude this flow. Yeah. Yeah, I think it's the fourth one.
Okay. Okay, so now we have a whole new mess of crocodiles. Okay. Head length was used to predict body length. So which is the dependent variable? Head length doesn't change. Body length is dependent. So I think it's body length, right?
Yeah, it's body length.
Okay. 95% confidence interval. Oh my gosh. Okay, here we go. This will take forever. Okay.
The 95% confident interval.
Oh my gosh. Can we do this without doing all the graphs and stuff first?
I think so.
Oh, good.
Because you're just doing the
Regression. Okay. Head length is independent. Body length is dependent.
I was like, I can already imagine how I'm going to know.
26. Confidence intervals, 95%. Okay.
Oh Can you close that?
Put your answers for the margin of error. Okay. How do we know what the margin of error is?
Oh, you have to put in it. Go to the statistics and yes.
Seriously, I have no clue on the margin of error. Oh, is it what the difference of the confidence interval? Really, I have no clue.
Let me look. It's got to be something that we have to like go back to other lessons and remember.
Yeah.
You know how they always like to do that?
Yeah, they do. Okay, margin of error. 218. Eight, 103. Divided by 2. Okay, I'm going to put 0.443.
Oh my gosh, I can't even open these things. My computer's freaking out.
Okay, hang on. Yeah, okay, so look, it says calculate the interval size, right? Confidence interval. So did you guys get 8.103 and 7.218?
I can't see mine yet.
Oh, okay. Anybody else have their lower and upper bounds?
No, not yet.
No.
Okay.
Get that.
So I think what it is find the in-between space divided by 2. That's what I'm going to try. Based on your lower and upper bounds, what can you say?
Okay, yay. I finally got it. Okay.
Oh, okay, good.
Analyze regression layer.
And I'm on the last question.
What is it? Body length is the dependent?
Yes.
Head length is independent.
Yeah, there was something in one of the things that I read that made it seem easy in my mind. Maybe it was in the homework. Anyway, it said that usually the one that you have is the easier one to calculate. So if they're going to measure a crocodile, they're measuring the head easier than measuring the body. So it's usually measure the easier one and then make your prediction on the harder to measure or or the less
Yeah.
expensive to go to the more expensive. I don't know. It made sense in my mind.
Did you get .04? I put it in.
I got what for question 15? Is that what you're on, Mary?
15.
For
For the lower
15,
bound.
I have .443, but I haven't submitted mine yet. I'm done with all my questions, so I can.
Oh, come on now.
So what did
No,
you get for the lower bound?
I got 7.218.
Okay, that's what I have too.
Oh, good.
I just wanted to make sure that mine was working correctly.
Yeah.
So, and the upper bound
Okay.
was 8.103.
Yeah.
Okay, so the margin of error, you put 0.443.
Yeah. Because I took the upper bound and subtracted the lower bound to find the distance between them. And then I split it and divided it by 2. So it's going to be plus
Yeah.
or minus that to get from the lower to the upper. I don't know if it's right because I haven't submitted mine yet, but that's what I'm going to try.
It's a good guess though, so we'll see.
I know.
Okay, so based
Oh,
on your
wait.
lower
I don't
bound.
have
What?
one of mine saved. Oh, I just didn't save it. I marked it, but I didn't save it. Okay.
Okay. So based on your lower bound and upper bound from the last 2 problems, what can you say about theta 1? Oh, okay.
I don't know if it's right, but I'm thinking it's the second one.
I was thinking
Well,
it's the
the only
first one.
thing is whenever it's always told us it's never there is a 95% chance. It's always you're 95% confident.
Oh, okay.
So I don't think it's the chance one.
Oh, okay, good.
I think it's the first one.
Yeah, after you
Yeah.
said that, then I would say the first one.
Let's just try the first one.
Okay, I'm gonna submit mine.
Okay.
That's
Oh, dang it, I missed 2.
Okay, which
Okay.
one?
So, number 6 is not the residuals form a linear pattern. I got that one wrong.
Okay.
Oh, I think it's the first one.
And number 8 is not all 5 boxes. Shoot. Dang it. That does not help us. Okay.
I was gonna say I feel like it's kind of hard to get all 5 boxes, but
Yeah.
just because based on the curvature, it's supposed to like be different. I don't know. Let me see. I have to. Dang it! I have to do the graph again, or I can just look at your picture you sent me.
Yeah. But we got the margin of error one right.
Hey, good job.
Yay, go us. Okay. I have to start mine again.
Not normally distributed. Okay, because there's an outlier, I think it says if there are outliers in the residual plot, that suggests that the error terms are not normally distributed.
Oh, okay.
And it looks like there is at least one outlier. I don't know, this could be a megaphone in a way because it is on one side they're closer together and then they fan out.
Yeah, but on the video, the guy showed me total. Oh, well, I don't know. It could be.
I'm just saying, it just says a megaphone shape occurs when points tend to be closer together on one side of the graph and farther apart on the other side of the graph.
Oh, yeah.
Which would make it kind of looks like that in that graph. So I'm going to try that. So if there's a megaphone shape apparent in the residuals, it suggests that the variance of the error terms is not constant for all values of x. So it's not the variance of the error term is constant.
Wait a second. Did we skip over number 6?
I don't remember what 6 was. Oh, I was just guessing it's the first one.
Oh. Okay, I see. I'm going to wait until somebody else puts theirs through.
I see. Which one are you talking about?
8.
8?
It suggests that there's a
Oh, I tried.
residuals depending
I tried the first one, the third one, and the last one, and it was not right.
You tried the what?
Okay.
A, C, and D.
Yeah, they're not normally distributed. I know that.
Oh, let's take a peek. And it's not A and D, or the first and the last one.
I don't know.
I know, right?
Because it doesn't say that on the based on the pattern. Let's see how farther apart. If there's a megaphone shaped parent in residuals, it suggests that the variance of the error term is not constant. I don't think it can be the first and the last one because it's saying there's a linear relationship and the other one's saying that they're independent.
Oh. You know what they should do? They should give us the ones that we got right.
I know.
So we don't have to go again. Yeah.
Okay, so for observations are independent, all it says, what you hope to see is, oh, dang it, I just messed myself up, is knowing the value of one of the y's tells you nothing about any other points.
But that's true. I think that the last are both.
Are both what?
I think those are both checked because those are the ones that said you can't really check this, but you have to just rely on the fact that they were calculated the right way.
Well, it isn't a hot dog shape, though. And in the table on the homework and in there, the requirement summary, a linear relationship says, oh, how to check is a scatter plot. So we actually have to look at the scatter plot, which is a dog shape, I think.
Efficacy. Okay, wait. There's four grading. So, what was the thing? Observation independent.
Normal error term.
I don't know, maybe the last one is. Right.
Well, when we did the QQ plot, the plots were close to the line, weren't they?
Yes.
So that means that requirement is met, and it's a normal error term. Which I'm not really sure which one that is on there. Is it the variance of the error term is constant?
Yeah, that's the QQ plot. If they're close to the line, the error term is normally distributed.
Then it's normally distributed, or the variance of the error term is constant for all values of x?
Oh, maybe that's the wrong one.
Okay, so it's got to be normally distributed if it's the QQ plot.
Yeah,
because x's are known constants.
I think it's one.
Oh my gosh. Okay.
All right, I'm just going to submit next.
Was the scatter plot, though, a hot dog shape?
Yes.
Okay, so then it is the first one. I don't know if they're independent, though.
I don't either. They're confident. It might affect their score.
It just said, well, on the plot, it would say knowing the value of one of the y's tells nothing about any of the points.
Yeah, but in this kind of a graph, if they're fairly confident, then it kind of correlates with a good score.
Gosh, this video is like echoing so much, I can't really hear you.
Crazy echoing. I don't know.
I wish I could show you. Okay, 1 second. I'm just going to do the first and the third one and submit it and see.
You're going to check the third?
Yeah.
Okay.
I missed 2. So
What was the other one? I think?
well, I got 6 right. The residuals are between -40 and 25. So I missed 8. And then what other one did I miss? I missed 13. I thought it was there is insufficient evidence to conclude that the slope of the regression line is not 0.
The fourth one. Number 4. Did you get 6?
It was there is sufficient evidence?
No, sufficient. There is sufficient evidence.
Sufficient. I heard insufficient. Whoops.
Yeah, it's the last one. Okay, so we submit. Did it submit the first time?
That was my first time.
I'm doing my second time, and I'm hitting all of them except for the second part on question 8. I think that's right. So I'm going to try it. Dang it.
You still get that one wrong?
No, I got it wrong.
I don't know what it is.
Yeah. Oh well. So it's still 94%. So I'm cool with that.
What was 17?
Sorry, Mary. What did you say? I couldn't really hear.
17.
17.
What was it?
17 is 8. 103. Is that what you have?
17 is 8.103.
I barely can hear you.
Maybe it's 1, 3, and 4. Oh, maybe you don't mark the fourth one because you can't tell just by the plots and graphs. Like maybe it's saying what can you see only from looking at the graphs.
Yeah, I think you're comparing the 3.
Yeah, well, I don't know. I'm over it already because I've done my 2.
Yeah, I'm just going right through and redoing it. I mean, everything else is right, so we'll just have to figure it out later.
Exactly.
Okay.
Yeah, it's all good.
Yeah.
You guys can go. I'll post this if you want to.
Yeah, I've clicked out of my test already, so I'm done.
Okay. Well,
I'm just re-entering things.
All right, cool. Thanks, guys.
thank you.